Alright, so you're going to work from inside out. Now, here I just want the arctan of 1. Where does tangent live? 1 and 4. Very good. Remember, tangent is y divided by x. So what reference angle am I working with here? Oh, Lord. Come on, y'all. What is it? Pi over what? Pi over 4. Pi over 4. Pi over 4. The tangent's positive, so what quadrant would that be in quad? 1. So what is it? Very good. Okay. So, looking at your study guide right here, we reviewed graphs yesterday. We talked about the domain and range. We talked about amplitude, period, phase shift, vertical shift. We just talked about inverse trig. So we kind of have reviewed Chapter 5. Chapter 6, trig functions, right triangle approach. I'm about to review this right here, this one right here. 6.1 angle measure. You got to be able to convert from degrees to radians, and radians to degrees. So let's look at these examples. I want 15 degrees converted to radians. What do I multiply that by? Pi over 180. Very good. Okay? These are relatively simple. Alright. 15 goes in 180 12 times. That leaves me pi over 12 is my answer. Now this is in what form right here? Radians. So I'm going to go to degrees. What do I multiply it by? And I do by over pi because your pi's cancel out there, guys. 2 goes into 180 90 times. 90 times negative 3 is negative 270. Three pi over 4. I want to go from radians to degrees. I'm going to multiply by 180 over pi. Pi's cancel out. 4 goes in 180 45 times. 3 times 45 is 135 degrees. Do y'all get the hang of that? Do I need to do another one? Alright, so there's some problems you can practice off that. You have 2 multiple choice about that. Then this next part right here, turn to the back of your study guide. So we finished reviewing 5 and 6. So on the back of your study guide, look at number 2. This is one of your short answer on the final exam. It says, let theta be an angle in quad 3. Draw you a picture. Such that tangent equals 4 over 3. What is the definition of tangent? Y over x. So which one's your y value? 4, and your x value is? And they're both in quad 3, so they're both what? Negative. Miss Sheshway, it doesn't say what negative divided by negative is a positive. That's why it appears 4 over 3 is positive. You want the other 5 trig functions. Okay? How do I find this hypotenuse of this right triangle? And the resultant's always what sign? Positive. Alright, so now we're ready to find the other one, sine theta. At my angle right here. You can either put the angle here or you can remember, sine deals with which one, guys? The x coordinate or the y coordinate? Which one's your y coordinate? Negative 4 over 5. Or you can think of it as opposite over hypotenuse. You can think whatever way you remember. Okay, cosine is what? Negative 3 over 5. What's the inverse of sine? Cosecant or secant? Secant. Come on, guys, wake up. So this would be negative 5 over 4. What's the reciprocal of cosine? Secant. That's going to be negative 5 over 3. I would advise everyone to have their study guide out, writing this down, or I will not go over another problem and you're on your own for your final exam. What is cotangent of theta equal to? You flip this, it's going to be what? 3/4. Okay, That is, you have a question just like that. Question just like that is your short answer too. So make sure you study this section. Okay, now I'm not going to review this because that's what we're doing right now. That should be fresh on your memory. Okay, so you just need to go back and look at that. So I'm going to cross that one out. And look at chapter 11, conics. I'm going to tell you, I'm not going to review that because I'm only putting circles. I did not put ellipses. I did not put hyperbolas or parabolas on your final exam. Let me see what I asked you in your final exam. So you can mark in your notebook right now what you need. Sneak peek. Boom, 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 boom. No. So it's 1, 2, 3, 4 pages front and back. 45 multiple choice, 5 not. Okay, what did I got to ask you about the circle here? Oh. This is the only thing I asked you about a circle. I give you the center, and then I give you a point that's on the circle. So how do you find the radius? Find the distance between the center and the what? Point, and that gives you R, so you square it. Is everybody good with that? That's the only thing you got to know about a circle. So, I'm going to mark that one off, and now we're going to focus on these other 3 from that point on, okay? Okay. Are there any questions? We good? Is this okay how we're reviewing? Okay. Moving on. But that Wednesday, before that exam, I will review whatever we hadn't reviewed, okay? We probably spend it on polars if I had to guess at the moment. All right. First of all, I just want to tell you, I heard from a lot of you about your ACT. I'm extremely proud, juniors. Extremely, I could not be prouder. I am just extremely proud of you and your work ethic on that test in March. And they're going to keep rising. They're going to keep rising. I can't wait to see what you do before you graduate high school. But at this time, if anybody needs to move up to a category, Jake, you got a big club you going to. What club you going to? I'm so proud of you. Does anybody need to move to the 25 club?
There is 20 clubs.
It's over there, Jake. 30 club. TJ, have you moved to the 25 club? These are mild moments that we need to be happy of. Who else?
Jake, will you sign a sticky note for me?
Yeah, you need to move up, don't you? Zach, I'm proud of you. Be proud of your accomplishments. No, you leave it there, but you just put another sticky note. Get you a sticky note right there. Be proud. Be proud.
No, what color do you want? Pink, if you have it.
All right. Now, we're going to take our time. We're going to take our time and go back through that lesson from yesterday and make sure we got it, okay? Is everybody good? We got 3 examples today that we're going to go through slowly. Okay, so turn to your notes from yesterday, and you're going to have 5 for homework. You ain't had homework in a while, so make sure you do it tonight. Here we go. What page are we on?
15.
Okay. Page 17. All right.
Will we be doing page 16 now?
No, you get the brief version of derivatives because we're running. As long as you get this big idea, you're gonna be ready for calculus. But that was kind of a more just why it is what it is, and now we're just getting to the meat of it. All right. So, guys, we talked about the derivative yesterday, and it is the AK slope generator. Okay, the derivative is the formula that you can find the slope of that tangent line at any instance on that function. That is the instantaneous rate of change. So what is it? This, like on this one right here, we got 2x plus 3 for the derivative of x squared plus 3. So what is the significance of that? That is the formula that you can calculate the slope of a tangent line at any point in that function. Does that make sense now? So that is the generic formula for the slope of the tangent line. Okay, so if you get a positive derivative value, that means the function is what? Increasing. If you get a negative, it means it's what? And if it's 0, it's a special either local min or local what? Or turning point. Okay. So let's look at number 6. We want to find the derivative of this. You said, Miss Chester, that's a long process. Oh, there's shortcuts you'll learn tomorrow. But right now, you have to learn the formal definition, and then tomorrow, I'm going to show you the shortcut, and then it's so much easier. Okay? You said, Miss Chester, I'm going to have to do the formal definition on test. Yes, because you got to be able to use this formula. All right, so I want to find the derivative of this. Remember, I'm not giving you this formula on the test. The formula for the derivative is this. How do you read this symbol right here? F what? Prime. That's how you, if you say F prime means you're finding the derivative, that little apostrophe there. Now remember, this, you can see this symbol means derivative, or this symbol right here, d of y over d of x, okay? You can either see prime or d of y over d of x. That means derivative. Now, we only do the simple derivatives. When you get to calculus next year in AP or college, there's a lot more rules. We just do the simple ones this year. All right. So right here, we have the function. (3x squared plus 12x minus 1). Now, if you want to do this, I'm fine with it. If you want to come under and find this part first, and then this part, and then take the 2 and plug it into the formula, that's fine, okay? Because if you try and do it all at one time, that might get too much for you, okay? So we're just going to, I'm going to find the f of x plus h part first. All right. Okay, so I'm going to find that part first. I'm going to plug that in for my variable. Okay. Y'all are all intelligent young men and women here, so you probably can foil this in your head by now. X plus h squared. What would that be? What's the first one? And then what? 2xh, won't it? Because you're going to get xh and an xh. That gives you 2. You said, Mr. Chester, does it matter to put h or x first? I always put the one that comes alphabetical, but it doesn't matter. So I'm going to put plus 2hx and then plus h squared. If you can't do that in your head, go to the side and pull it out. Don't be ashamed of that. Okay, then I'm going to distribute. That's 3x squared plus 6hx plus 3h squared plus 12x plus 12h minus 1. if I take x and I plug it in right there, if I take x and plug it in, does it change it? So you really don't have to do any work on that. Now let's substitute it back into our formula, okay? The limit as h goes to 0, I'm going to put this in there. What's that minus do to everything in that parentheses? Changes sign. You say, Mr. Esther, I don't have to do both those steps. Can I just do it in my head? Can I just skip this step and just go on and change all the signs? That's fine. I'm just showing people where I'm getting this at. So, yes, if you pass showing every one of these steps, you don't have to show all those steps. That becomes a negative 3x squared minus 12x plus 1. Now, yesterday I talked about at this certain point in time in this junction, in this problem, what should cancel out in this problem? Everything that doesn't contain a what? H. If it doesn't, then we did something wrong. So 3x squared negative 12x, that cancels. So I'm left with the limit of h goes to 0 of 6hx plus 3h squared plus 12h over h. Okay, so I have the limit as h approaches 0. I tried direct substitution. Does it work? So what toolkit strategy I'm going to do on top? Factor out of h. I would just do it. You can factor out 3, but what you're doing is here just trying to get rid of that h on bottom. So you could, but it's not going to do much with the problem. These h's cancel out. Now I'm going to substitute a 0 in for h. You said, why don't you do it for x? This is the variable that's approaching 0. This is the one you're concerned with. So I take 0, I plug it in, that goes away. So what's your equation? 6x plus 12. That is f prime. That is your derivative. That is your AKA slope generator. That right there, if I asked you what was going on at x equals 1, what's the IROC? What's the instantaneous rate of change at 1? You plug 1 in, I get 18. That would be my slope of the tangent line going at x equals 1. Does that make sense? That means if it's positive, it means the graph is doing what at x equals 1? Increasing. Does that make sense? Okay. So what did the problem want to find out? They want to know what is going on at x equals negative 2. 6 times negative 2 is what? Negative 12 plus 0 is? 0. So is it increasing, decreasing, or turning? Turning at that point, at this number. So at x equals 2, that is the slope of the tangent line. And we're going to graph it in a minute and see what's going on so you can see. Okay, x equals 1. At x equals 1, I plug that into my derivative. 6 times 1 is what? Oh, I just did that. 6 plus 12 is 18, okay? So here's my derivative, and here's the slope of my tangent line at those 2 points, okay? So let's see here. It is 3x squared plus 12x. Oh, thank you. Why is the thing froze up? Why is my whole board froze up now? Get your graph calculator out. Graph it. 3x squared plus 12x minus 1. Well, you clearly see at x equals -2, that's the vertex down there, isn't it? So it's turning from decreasing to increasing. That's why you got a value of 0 there. X equals 1. What is the graph doing at x equals 1? It's going to what? Infinity. That's why it's increasing. Does that make sense? Okay. All right, let's look at the next one. My page went from 17 to... Can I see your problem? Okay, so on this next one here... Oh, this one looks good. Ooh.
You gotta do one for fractions.
Mm-hmm. Here we go. All right.
Are you going to put it on the board?
Oh, thank y'all. All right, so here's our next one. This is number what? 7. Okay. All right, so here we go. We're going to find the derivative using the formal definition. This is the formal definition. The limit as h approaches 0 of f of x plus h minus f of x over h. Alright, if I'm going to do f of x plus h first, take that, plug it in, I'm just got, that's all I can do with that. Okay. Alright, that's all I can do with that. Do you agree? So now I'm going to plug this in, okay? The limit as h goes to 0 of 1 over x plus h minus 1 over x all over h. What does that look like, what we've been doing? Complex what? You remember us finding common denominator in our toolkit strategy? That's where this comes into play now. Okay, I'm coming to the side. What would be my common denominator between these two guys? And x. They got to be both of them. So I'm going to come over here.
Wait, is the x not like in the x and the x plus h doesn't just count as that?
No, because you can't multiply x by anything to get x plus h. So you have to settle for both of them. Because if you multiply this by h, you have x h. You don't have x plus h. So you have to settle for both of them. All right. So here I multiply this by x. I multiply the numerator. Here I multiply by x plus h. I'm going to multiply that by h. What does this minus do to everything over here? These x's cancel out. So I'm left with, I'm going to go back to my formula because I just took care of the numerator. I'm left with h over x times x plus h all over h.
How wouldn't the h be negative as well?
It would be. Thank you. Now, that's a little complicated right there, fraction, isn't it? So would it be in your best interest to come to the side and like write out what this division means? Yes. I'm going to come over here, negative h over x times x plus h divided by h. What happens to these h's right here? -1. So this, I've done all my toolkit strategy, so I'm going to go back to this original problem here. Right there. I've done find a common denominator, I factored, not factored, but I found a common denominator and I simplified that fraction down. Now I'm going to apply direct substitution. I take 0, I plug it in. What now, buddy? What now? I just canceled these h's out, and that's a -1 times 1 right there. Yeah. If I take 0 and I plug it in, do I get 0 in the denominator? No, I get -1. X plus 0 is what? X plus 0 is? X times X is? Okay, you're good. That's your derivative. That's your derivative right there. AKA slope generator. That would tell you the instantaneous rate of change at any given moment on that graph. Now, what areas are we concerned with? We're concerned with x equals -2. So let's plug that in. What is the slope of the tangent line? What is tangent line? How many times does a tangent line touch a graph? 1. A secant line does what? Twice. That's average rate of change. Instantaneous rate of change is a tangent line. So I'm going to plug -2 in, and you get what? -1/4. Okay, it's negative. So what's going on in the graph at that moment? It's what? Decreasing. Now, x equals 2. I plug that in, I get -1/4 as well. That's the slope of the tangent line at those 2 points. Is it making more sense, day 2? So this is, what is this? This is the formal definition of the derivative. The formal definition of a derivative. All right, let's look at number 8. We have f of x equals square root of x. Okay, so we're going to find f of x plus h first. That gives me square root of x plus h. Oh, thank you. So now I'm going to use that formula, the limit as h approaches 0 of f of x plus h minus f of x over h. Plug this in. Minus f of x would just be square root of x, wouldn't it? All over what? H. I tried direct substitution. What do I get in the denominator? 0. So what toolkit strategy can I use here? Rationalizing the what? Numerator. Rationalizing the numerator. This times this just give me x plus h. This times this will give me positive. This times this will give me negative. What would happen to those two things? So do I even have to write that? No. Negative times a positive would be what? Negative x, because the square root. I didn't put this step because I think we can skip it. I did this times this and got x plus h. I would multiply these two. That give me a positive. That would give me a negative. They cancel out, so that's why I didn't write it. Is anybody confused? Now, this times this would be a negative, and the square root cancel out. Oh, yes, I just hadn't done it. Yeah. They're going to cancel out, so you're left with h. Now, h times this plus h times square root of x. So that's left with h. If I did direct substitution right here, would I still get 0 in the denominator? So what toolkit strategy can you do in the bottom denominator to get those h's cancel out? Factor it out. That cancels out. I'm left with 1 over the square root of x plus h plus square root of x. Now apply direct substitution. I have 1 over. If I put 0 in for h, I have square root of x plus square root of x. Can I add those two radicals? Yes, they have the same thing under the house, don't they? So that's going to be 1 over 2 square root of x is your derivative. That's f prime is your derivative. 1 over. You know you're done when the h's are gone. H's are gone. That's when you know you're done with problem. So your derivative would be 1 over 2 square root of x. Okay, if I took, and I want to know what's going on at 36. With x equals 36, f prime of 36, and then you notice how I use that notation. F prime of 36, I'm plugging 36 in for x. Square root of 36 is what? 6 times 2 is? The slope of the tangent line is 1/12 at 1/12 at the moment. It's positive. That means the graph is increasing. At x equals 81, f prime of 81, make sure you use this notation. 1 over 2 square root of 81. That's going to give me 1 over 18. It's not too bad, it just takes a while. I think it's going to be better understand it today. Okay, we're not going to start this. I'm going to show you it's the easiest way to do derivative. We're going to do this tomorrow, but let me show you how easy this is. That's the long way. Okay, let's just say we had this right here. Okay, let's say I want to find, you got 5 problems from it, but let's say we want to find the derivative of this. You don't have to go through all that formal definition. You take this, multiply this by this. What's 3 times 4? 12. Take 1 off the exponent. Be x what? 2 times negative 2 is? Take 1 off that is what? 1 times 1 is? 1 minus 1 is? Do I need to put a variable there? Because anything raised to 0 is what? Anything raised to 0 is 1. Do I have a variable here? Do I have an exponent to bring down?
We can't see.
Well, that's all you had to say. I'm sorry. I had minus 7. Do I have a variable here with an exponent? So I don't worry. There's your derivative. That's as easy as it gets. All you do is bring the exponent down, multiply it here, subtract 1 off the exponent.
Do we have to do it this way?
You have to on the test for 2 of them. But the rest of them, you do it like that.
What about like on the final exam?
You do it like this. I don't put any of the long ones. Okay, ready? Let's say we have negative 6 x to the 4th plus 5x cubed minus 2x squared plus 9. Okay, so you go here. 4 times negative 6 is what? Negative what? Take 1 off that. That's going to be what? 3 times 5 is? X what? 2 times negative 2 is? X. Do you have to worry about just the constant? That's your derivative.
How did somebody figure that out?
I don't know. There's some bored people back in the days that figured out between the definition and that. Yes.
So like, how would you do that for like
Okay.
the ones we just did?
Okay. 1 over x. You ready? Now you're going to learn this. You remember us in the math workshop having to rewrite stuff with negative exponents? How can I rewrite that? X to the negative 1, couldn't I? What's negative 1 times 1? Negative 1. The rule is subtract 1. What's negative 1 minus 1? Okay, how can I rewrite that? Isn't that what we got a while ago? So the first thing you do when you have fractions, you rewrite it with negative exponents. Bring this down. Negative 1 times 1 is negative 1. You always bring the exponent down and multiply. Always subtract. So negative 1 minus 1 is not 0. Negative 1 minus 1 is negative 2. Well, then you rewrite it without negative. And isn't that what we got a while ago? So that's why we did the math workshop working with negative exponents. Now this is the derivative. In calculus you'll learn something about the antiderivative, which is the inverse of that. So tomorrow we just keep learning these shortcut. They're not shortcut. There's rules to this, but the first 2 days you learn the formal definition, so you will respect the rules on the next 2 days. On the homework, I use formal definition. Formal definition on homework. Tomorrow we'll start this. Tomorrow we're probably going to do a quick review of vectors, because that won't take long. Chapter 9, y'all good at vectors. And then all we have left is go over Chapter 7, Chapter 8, review of that. Everybody good with that? Vectors is mainly add, subtract, and dot product. That's on your final exam. Yes. Thank you.